So, look, mom, no wires, or monitoring houseplants on Grafana Cloud. A bit of introduction. I'm Giordano, Gio for non-Italian speakers, much easier, I found. I'm from Rome, Italy, but I moved to sunny Lisbon more or less 3 years ago. As Ford said, I'm a software engineer at Grafana Labs. I joined a bit over 1 year ago, and I'm part of the observability squad. Among other things, we take care of Explore and some of the core data source plugins, such as Loki, Prometheus, and Tempo. About the presentation, today we're going to talk about how I'm setting up a fairly simple and cheap monitoring solution for my houseplants, and in the process we'll learn a bit, hopefully, how Bluetooth Low Energy works. So, why this is even a problem in the first place? So last year I moved to this very nice apartment with a fairly nice patio, and like everyone else, I assume, I started picking up some hobbies because of the pandemic, and yeah, some of them were quite successful. For example, I picked up chess after a long time, and for the first time ever, I managed to win a game against my father, which was for me a huge achievement, like huge. Some of them were not really successful, and by that I mean I'm not that good at art as I remember I was. As you can see, like, I'm not really done for painting or sculpting. And worst of all, I must admit, I'm not brilliant at taking care of my plants. And that's not because I cannot pour some water into the vases. It's just that I plain forget about it. So this is what I came up with, very basic prototype. And we're going to talk about what I did and how. First of all, let's start with a bit of introduction to Bluetooth Low Energy and how it works. When reading resources online and doing some Google searches, you'll jump into some terms like GAP, GATT, ATT, advertisement. And I mean, to me, at least from the very beginning, they didn't make any sense at all. So we'll go through a few concepts, just enough to understand what we're going to build and how I built what I did. Bear in mind, this is not supposed to be by any means an extensive, detailed, or not even accurate description of what Bluetooth Low Energy is. So take everything I'm going to say with a grain of salt. First off, let's start with Bluetooth itself, with BLE. BLE, formerly known as Bluetooth Smart, is a personal area network that operates on the 2.4 gigahertz. It was originally released by Nokia in 2006 under the name of R.I.P, and then included in the Bluetooth 4.0 specification in 2009. It is different from Bluetooth Classic, and it's not compatible with it. Also, I think a single device might implement both BLE and Bluetooth Classic. Your phone, for example, is a use case for that. It is designed for low power consumption use cases with a relatively low range. I mean relative because it can actually, with some tweaks, can go up to a few hundred meters. The protocol that define how devices discover each other, for example, when you search for your earbuds from your iPhone or your phone from your car, is called Generic Access Profile, or GAP. GAP also controls if and how different devices can talk and connect each other, subsequently defining the role in the network and the related network topology. GAP defines a few roles. We can see 4 of them here that act as clients or servers. And a device can generally assume one or even more of those roles at the same time. So broadcasters are devices that periodically announce their presence via advertisement packets and broadcast them to every device nearby them. Observers listen to those advertisement packets, but they don't connect to them. Then we have centrals that are pretty much like observers, but unlike them, they may connect to other devices in order to send or receive data. And then we have peripherals, which are like broadcasters, but they may allow other devices to connect to them. So we talked about advertisement packet, but what does it actually mean? Advertising is how BLE-enabled devices allow other devices to be informed about their presence, what kind of data they offer, and how they can interact with each other. For example, a heart rate monitor can periodically announce they have some measurement available for reading, and that they may be able to be connected to in order to deliver the data. This is a very simplified diagram showing the structure of an advertisement packet. And as shown here, we have roughly 31 bytes to put our data in. For a more detailed explanation, I found this link very useful to understand how advertisements work in Bluetooth Low Energy. So what we want to achieve, let's jump to the fun part. This diagram represents roughly what we're going to build. We'll have a set of broadcasters gathering data from various plants. And the data is as explained before, is going to be sent over Bluetooth advertisement packets to everyone. And we'll also build an observer that will listen for that data. And of course, we know we want to visualize the data in Grafana because, I mean, Grafana meetup. So I guess that was kind of obvious. Let's start with the broadcaster. For this project, I'm using an Arduino Nano 33 BLE, which is a development board built around a 32-bit ARM CPU with 1 megabyte of flash and 256 kilobyte of RAM. I will also use a DHT11 sensor and a soil moisture sensor. The code is quite simple. We can see it here. What it does is basically turns on the Bluetooth stack, reads some humidity data, temperature, and soil moisture, prepare the data for the advertisement packet, set the manufacturer data or that payload we saw before, advertises the data for 10 seconds, then stop advertising and turn off everything that we can turn off. In this example, like just turn off the Bluetooth stack, and then sleep for 30 minutes. Now, the schematics. Also here, the schematics are quite simple. One note though, as you can see, the soil moisture sensor isn't directly connected to the 3-volt pin, unlike the DHT11 sensor. This is because this type of sensor is quite susceptible to erosion, especially when continuously powered. To overcome this, we're going to turn it on just in time to get a reading from it, and then we'll turn it off immediately. Power consumption is not really a concern in this phase, but ideally, it could also help reduce it a bit. Now the observer. Again here, as mentioned before, it's really quite simple. It listens for advertisement packets, and when they come from one of the configured addresses, it parses the advertisement payload and extracts information needed, the information, and logs the information to start an output. Since the broadcasters don't know anything about what plant they're measuring, in the configuration file, we'll also assign an alias for each one of them so that we can include that in the logs. Also, in this case, the code is quite simple. It's available in the repo, but what we do is we read the address from the Bluetooth advertisement packet, from the Bluetooth device. We read the data, we extract our counter, which is just a random number from the advertisement payload, temperature, humidity, and soil moisture data, and then we log data to standard output. So at this point, we have to decide or figure out how to store the readings so that we will be later able to query and visualize our data in Grafana. We can actually go crazy here. I guess every solution has its own pros and cons. And I was personally considering Prometheus as it comes for free with the Grafana Cloud free plan. But that means writing a bit more code, and the fact that they can scrape sensor data just in time is a bit of a bummer. I would have actually had to write an exporter, but then I had to cache results on the observer itself, since the sensor will go offline for about 30 minutes. So it didn't seem like a perfect fit. But what about none? And what about instead of using anything, we just go with what we already have? And by the way, did I mention I'm lazy? And that's why my plants were dying in the first place. As mentioned, I'm already generating logs for debugging purposes with all the data I need. Turns out, LogQL is able to do magic queries to create metrics from log entries. Plus, Grafana Cloud comes with an actually useful free plan that allows us to store up to 50 gigabytes of logs with 14 days retention. Also, given that I'm using Grafana agent on my Raspberry Pi to collect system metrics and send them to Grafana Cloud, I don't have to manage yet another piece of software. So in order to do that, we first need to configure the observer. What we're going to do is to redirect the output from the observer to a file that Grafana agent can scrape. To achieve that, I created this simple system unit file in my Raspberry that appends logs from standard output to that configured file, which is, as you can see, varlog greenskeeper. Configuring Grafana agent is quite simple as well. This is the relative part of my configuration. We'll tell Grafana agent where to find those logs and how to interpret them. For example, by replacing the timestamp with a field from the log line itself. And this is how it actually works. So the first part we described before. We now have a Grafana agent that sends data, that scrapes data from our logs and ships them to Grafana Cloud. And from Logi, we can actually query and monitor our data. Those are the queries I'm using to generate my dashboards and alerts. LogQL has this nice way of generating metrics from log entries. And you can find more, and you can read more about metric queries in the link I put on there, which all the links will be available at the end of the the slide, so no worries about that. And here I'm gathering data for temperature, humidity, and soil moisture. And the legend itself is going to be based on the alias that I have in my log line. We can see how it works here in my live dashboard. So we can see the temperature for those two plants. And by the way, like, they are basically all succulent plants, so I didn't have to worry about watering them while building this presentation. And as you can see for the soil moisture part, I'm also having an alert which was firing since a couple of days ago. But yeah, again, since it's a succulent plant, I'm not really worried that it will die anytime soon. So going back to our presentation, this is my dashboard. And here, this is an example alert fired a couple of days ago, telling me that my Sansevieria cylindrica needs some water and is probably about to die if I don't do that anytime soon. Next steps and consideration. I might actually want to consider more accurate sensor, given that the DHT11 is not really accurate, but I don't know, it felt like it's pretty cheap, quite easy to use. It's like available like everywhere. I might probably have to design a PCB and optimize it for low power consumption. Although this comes with, like, we cannot use Arduino for that as it's not really power efficient. And probably I should design my alerts a bit better to be based on the kind of plant I'm monitoring and not just based on the soil moisture. As mentioned, like I'm just measuring succulent plants that don't need water, but I might want to adjust these alerts for the kind of plants I have here, which I have around like 15. So yeah, I actually need to do that sooner or later. Here you have some references. By the way, this whole project was inspired by B-Parasite, which is a way better implementation of the sensor. And it's ready to be printed on a PCB. You can find it in that link. The work that that guy made is amazing. I really took a lot of inspiration from it. Then some my repo where you can find the code for those projects, both the observer and the broadcaster. Documentation for LogQL, the Grafana Cloud agent, and that's it. That was my talk. Hope you enjoyed, and thank you.
Thank you so much, Gio. While you were speaking, I do have a couple of the bits and pieces that you showed at home because I wanted to try it out. I have about 170 plants though, so this is going to be a costly endeavor if I want to do that. But I was thinking maybe I can cluster them per sort of room, because then they're the light sort of situation, and I guess sort of the heating situation will be the same. And maybe I can have like one sort of like I don't know, the one plant that will tell me whether the whole cluster is looking for some water or not. Anyway, I'll need to try and figure that one out. In the meantime,
yeah, actually, oh, sorry.
Yeah. No,
I was considering that as well, because as said, we have 31 bytes of data available, and right now I'm only using 7, which means basically like with a single device, I can control 4, no, even more, because like if they're very close to each other, then it's basically just 2 bytes overhead for each plant, because the only thing we need to measure is soil moisture, because temperature and humidity will be more or less the same. So yeah, with a single device, you can actually measure, I don't know, 15 plants, maybe. Okay.
And then figure out how the pets feel about all the cables connecting. But you know, we'll figure that one out.
Exactly.
we'll cross that bridge when we get there. I wanted to have a look at the poll that we did just before your talk, and I see that there's a large number of people that do not have houseplants, and I'm thinking, at all? How do you survive? They give you oxygen as well, people. It's healthy. And then there is the, yes, I put my finger in the soil, and if it's dry, the plant needs water. But you know, maybe after your talk, people are convinced that they should look into monitoring and automating this a bit more. I saw some questions in the chat, so let's have a look at those. I saw someone named Vlad who had a couple of questions, so maybe also a couple of houseplants. How about measuring the amount of light the plant consumes? I've done basic light censoring, but I'm interested in your thoughts.
Well, I mean, this is one of another sensor that we can add in. I also thought about that. The thing is that when I ordered it like 2 months ago, they told me it was going to be delivered like in
oh yeah, weeks. Remember?
Then
yes.
Yes, then it didn't arrive. I tried a local store that didn't have one. So it was like a bit of a journey. But yeah, like I think we have some pretty cheap sensors that comes for maybe 20 cents, 30 cents. And yeah, that will be also a nice addition. I mean, a lot of monitoring solutions actually measure lights, so that would be very useful.
Another question, Flathead, was which levels of moisture do you usually keep in percentages, maybe? So
that I still need to figure out. Like, the thing is that I'm lazy, I'm not good at gardening. That was the whole point of this presentation. But yeah, I feel that for one of my plants, which is down there, but I cannot get, it usually recommends the soil to never dry completely. So I set the alert at around 10%. But this is based on my sensor because, like I said, the sensors are not very accurate and they need some calibration. I found that 10% for the sensor I'm using is a good amount of like it's a good value, and I'm using that. But again, like I will have to iterate over that and set a value for each one of those plants.
Awesome, cool, thank you. So flat with an answer. I think 14 days retention on Grafana Cloud is not enough to figure out that moisture percentage. Well, that's probably true. Especially considering winter and summer differences. Yeah, fair.
So yeah, that's for the winter. That's true. Like I found out that last time I watered this plant was around 1 week ago, and the percentage dropped from 30% to 19%. So during the winter might not be the best solution to have like only 14 days. For the summer, actually, I found out that they tend to dry pretty quickly. So around like every 3 or 4 days, if they're on the outside, it's actually enough. But of course, like if we need more data, then we might want to explore different solutions like, you know, a not free plan, or we can also deploy our own Loki instance, or we can go for influx or whatever.
Honestly, I think we need a houseplant plan for Grafana. We'll work on that. We'll workshop it. Flat. Yes. We'll work on it. Awesome. Thank you so much, Gio. I think we're going to the next talk. There's some people that are asking for the links to the repo and so on. So if you could share that in the chat, Gio, that would be really amazing.
Yeah, of course.